guys. Thank you for coming here. Hope the weather didn't cause you much trouble with the traffic and stuff. Yes, dual last, I'll introduce myself real quick. My name is Piotr Siwczak. I'm a development manager with Mirantis. And on day by day, I work on a Mirantis product based on containers. And today, I'm going to be talking about modeling complex applications on Kubernetes. So you might be asking, like, what's complex applications? I mean, all applications are complex somehow. So I'm talking here about modeling like multi-tier applications when you got, basically you have dependencies between resources, and you need to provision them in certain order in order for them to work together. So you can imagine that if you have an application that has two layers, like database and web, you need to provision database first in order for web to pick up the database connection and work. So I'll show you how we can model the dependencies between different layers using Kubernetes. So what I'm going to be talking about today in a little bit more detail. Since I'm talking about those complex applications, I mean, you can assume that there are some complexities involved from Kubernetes side, and this is not that smooth. Otherwise, there wouldn't be such talk, and we wouldn't bother coming here. So I'll tell about the challenges. I'll tell what's missing in Kubernetes to kind of become a good platform for running complex services. And I'll introduce one tool that me and my team developed, which is called AppController, which enhances Kubernetes, which is open source community project, and then tries to tackle the problem of creating dependencies between services and employing complex applications. So let's start with the challenges. I mean, before we go to the next slide, I would like you to recall, there is one platform for microservices and a set of microservices that you probably use on a day-to-day basis. And basically, this is, our favorite operating system called Linux. I mean, it's usually given as an example. I mean, very often it's given as an example of very first microservices platform. I mean, if you take a look on how Unix and Linux are designed, this is set of small applications that you can combine together. Each of them has standard input, standard output, standard error, so they can communicate. You can chain them together to make some more complex systems. And your platform for running those small applications is basically Linux kernel and a set of shared libraries which abstract the computing resources for you. So if you take a look on how Linux architecture looks in a simplified way, you will see that kernel and libraries give you the resource abstractions, and you have some orchestration layer where you can put your apps in. But it can be an interactive shell like Bash. And for some more complex system, there is an init system. And I would like to focus a little bit on the init system. So with interactive shell, you just type the commands and they execute as you go. So it's like a manual input. Init system is more like for handling complex applications. There are a number of them, starting from ancient sysv init and then going through appstart to systemd, which is really funky nowadays. And the main value of these init systems is that during the system startup, they orchestrate provisioning of different complex apps. What is a complex app? A complex app in this case can be SSH. I mean, you need to start networking before you start IP tables to open a port for SSH, and then you start SSH. And imagine if you were supposed to do it, without init. I mean, your system starts, you need to go to the console, log in, launch the networking, launch IP tables, launch SSH would be unmanageable. So this init system, this orchestrator for complex apps, is a really essential app in case of Unix and Linux. So how do we compare Linux to Kubernetes? What are the counterparts? So what abstracts your computing resources in case of Kubernetes is pods, services, deployments, and all those constructs. And then as a counterpart of interactive shell, you got Kubernetes clients. I mean, you can curl against the API. You can also use kubectl, and this way you deploy the apps. But if you take a look on kubectl, it's more like a replacement for bash. It's, you type kubectl, the resource gets provisioned. To deploy another resource, you need to type kubectl once again. And there seems to be nothing like an init system that will allow you to combine like multiple calls to kubectl and create dependencies between them and thus form like, more complex applications. So basically what we get with kubectl, and when we run it and we want to deploy some complex application within one YAML file, it's just like, putting everything into a stir fry and let it simmer, and well, that's it. And what's the outcome of such operations? Like, the containers can come and go in different orders. So for example, we may have a situation where database container will be provisioned after the web server container, so there's going to be no connection. So there is basically no ordering. It's like equivalent of stir fry. If you put everything into the stir fry at one time, like meat, veggies, all this stuff, you will have a stir fry where the meat is dissolved, the veggies are still a little bit hard, and it's like uneatable. So the same with like kubectl in case of complex applications. So, but like if you take a look on pretty much every application, I mean, even quite simple like WordPress, it needs to have several layers. So if you deploy a and you need to take care of the ordering. So just like with a good stir fry, you need to put like heat oil, add garlic, add veggies and sauce, and add meat at the end. So this is how you should be deploying like more complex applications as well. They should, like the problem of ordering is always there. So if you take a look on even like a really simple application like a WordPress deployment from Kubernetes examples, and it's even like simplified because it doesn't contain the volumes. So you will see that first you need to create MySQL password as a Kubernetes secret resource. Then with the second kubectl call, you will create the MySQL service, and you will pass this password to MySQL service. And in the third step, you will need to create the WordPress deployment and service, which basically need to consume the database connection string, which is a combination of DNS name of MySQL service and a password from the secret. So even to deploy, like what I want to show, that if you use kubectl, it takes like 3 calls to deploy a relatively simple application. If you just put all these resources into one YAML file, they will get provisioned in random order, which can sometimes be, mostly it will result in success, but sometimes can fail. So hence the need for an init system and something to kind of tackle those dependencies. But you can ask yourself a question like, should it be really resolved on Kubernetes? I mean, like people have different ideas about it. I mean, Kubernetes is like Google's way of deploying application, and you can say like Google is smart, so they, probably got it resolved in a different way. I mean, so the truth is they can have some applications on their own which handle these failures and dependencies very well inside the app, and that's probably what they will be recommending. But there is a bunch of people who actually would like to deploy their existing applications with where the dependencies are not handled within their application. So that's where Kubernetes could do better in this case. So yeah, so deps seem to be needed, and there is like some evidence on the web for this. So there is I came across, when I was doing research for this presentation, across the post from CBL Labs, which says a common definition for a microservice we often hear mentioned is an independently deployable unit. And indeed, it is a good practice to design your microservices so they can start up successfully without requiring all kinds of other components to be available. But in the vast majority of cases, no microservices is an island. So you can see like this problem is being brought up. Another things, I mean, if you take a look on Kubernetes' competition, like Docker Compose, you will see that it also has a concept of dependencies. There is this depends on, oops, is that
yeah, there should be somewhere here. Oh, cannot find it, really cannot find the example right now, but you can express the dependencies between resources using Docker Compose. The same if you take a look on Mesos. It also comes with the concept of application groups, where you can express dependencies between different resources being provisioned. So with Kubernetes, actually, there seem to be nothing like this. And this is another funny example. So there is a simple script available on GitHub called Wait For It. I don't know if the author is there, but there's seemed to be a funny story about it. The guy wrote a simple script which you can deploy in the container that checks availability of a network server on another container and starts your service within your container depending on the availability of another port. And the guy told like, hi there, I wrote Wait For It in order to help me orchestrate containers. I thought it was a neat little script, so I published it. I assumed I would be its only user, but that's not what happened. Wait For It has received more stars than all of my other public repositories put together. I had no idea this tool would solicit such audience, and I was equally unprepared to carve out the time required to address my users' issues and patches. So you can see like the evidence is there that the problem really exists of orchestration, and you can deal with it in different ways. And actually, like, competition of Kubernetes is offering some solutions for this. And there's also like users specifically asking for it on Kubernetes forums. So if you take a look here, is there a way to express service dependencies? This is from probably like a year ago, like 2 years ago, and the answer is like, no, what you're asking is not currently supported. There is another one as well, like specify Docker, order Dockers run on Kubernetes pod, and the answer is again like Kubernetes currently does not allow specification of container startup dependencies. And the third one comes from this July, and the answer is like, take a look at this project, github.com Mirantis Kubernetes / AppController, which actually really smoothly takes us to the other part of this, to the second part of this presentation, which is AppController. So AppController is basically a trial, an attempt to resolve problems of dependencies of complex that are involved in deployment of complex applications using Kubernetes. It's an open source project created by Mirantis, but it's publicly available. Everybody can contribute. And I'm going to be talking a little bit on like technical details of it right now. So a really short summary of AppController. It's a way to express dependencies between Kubernetes objects. So you can create a sequence of objects, and they get created depending on like one after another. And this allows you to create a graph, and this, the Kubernetes deployment will be following this graph, and this way you can create like complex multi-tier applications in fully automated fashion. And basically, like to put it in one sequence, we added like a graphed deployment to Kubernetes. And there are two objects that actually form a graph, like two types of Kubernetes resources that get created in this graph. This is definitions, which correspond to nodes, and dependencies, which form edges of this graph. So we want to take Kubernetes from the state where if you are deploying WordPress application, it takes you like 3 kubectl create calls to creating it in one provisioning command kubectl create, and you give the YAML file with the graph, and you trigger the deployment using Kubernetes AppController. And all the layers get sequenced and provisioned one after another for you. How AppController is built technically. So here is your Kubernetes installation, and AppController consists of two things. AppController application, which is a Go binary, and Kubernetes API third-party extensions. So we deploy the binary inside a pod that runs on the Kubernetes installation. And we basically register two types of third-party resources, which allow you to build the graph, which are dependency and definition. So how do you model your application using AppController? So I told that in a couple of minutes ago that the nodes of the graph are called definitions. And first you need to basically create these definitions inside Kubernetes. And what the definition is technically. So definition is basically a wrapper around the regular Kubernetes object. I mean, if you take a look on, this is basically excerpt from the YAML file with the definition, you will see that it adds a couple of headers, like the API is changed to AppController, the kind is definition, and what's like below the definition is a regular Kubernetes object. In this case, it's like a database password, a secret. And what this definition gives you is that if you wrap Kubernetes resource with the definition and you load it to Kubernetes, it won't get created right away. It will only get created when you trigger the deployment of an application from Kubernetes AppController. So if you load this, if you apply kubectl create -f this file, it will create an object in Kubernetes, but nothing will happen until you trigger the deployment. So what a definition is, just a quick recap. It corresponds to a node in the graph. It's a wrapper over a regular Kubernetes resource. And the most importantly, defers creation of the resource until specifically triggered. So now, once we got the definitions in place, we need to connect them. So we need to specify in which order they will be provisioned. And we do it with the dependencies. So what a dependency is. A dependency is a third-party Kubernetes resource that allows you to create parent and child relationships between definitions. So in this case, we are creating a relation that MySQL password secret should be provisioned before MySQL deployment, because MySQL deployment needs to consume this secret in order to set up the root password. Yeah, so quick recap of a dependency. Dependency corresponds to the edge in the graph, links definitions together, and provides a sense of dependency on the resources, on the definitions. So once all of that is in place, we got it loaded to Kubernetes. Please be reminded that nothing got provisioned yet because we wrapped all the objects into definitions. We got all the graph formed. We can trigger the deployment using Kubernetes AppController application, like with the command ac-run. And then we can check the status of provisioning. We can see how the resources get provisioned and if everything goes fine with the get-status command. So just to recap the full workload. First, we create the nodes in the graph, which are definition objects. And we load these into Kubernetes. Nothing gets provisioned at this stage. We create dependencies. We load them to Kubernetes. Nothing gets provisioned yet. And then but the full graph is in place. And then we trigger the graph deployment using the Kubernetes AppController application. Yeah, so now there's going to be a simple demo of what I've just told you. So just so you can see how it performs in action. So I hope everybody can see my screen. Are the letters big enough for you guys, or you need to? Yeah. Okay. So in the left, I got my main window. On the right, I got my script, so that I don't need to type everything. I got. Okay. Let me just put it a little bit. Maybe just do it like this. Maybe it should be better.
She can't read the text, Piotr.
Yeah. Yeah. So you can see that right now there is nothing in my Kubernetes installation. So the first thing I'll do, I'll deploy the AppController. And the AppController basically runs as a regular pod, as you can see. And we got an image on this on Docker Hub. So what you need to do is create which will give you a pod, right? And we can test whether AppController works by running the status command inside it. Yeah, so you can see like there is no resource definitions, there is no dependencies. Yeah, nothing is loaded. Also, what we can see is that the AppController, if we curl on Kubernetes API, it registered 2 extra third-party resources, which is a definition, our node in the graph, and dependency, which will allow us to express the edges. And okay, so we got all the constructs in place that we've been talking about, and let's start deploying and modeling our application. So let me switch back to what we're going to be modeling. I'll show you. It's going to be a really dumb example, and believe me, AppController can do much more complex graphs than this. But yeah, this is just to show how it can get started. So our application is going to consist of let's say 3 layers. The first layer is going to be the database password in the form of Kubernetes secret. This password will need to be created before the database deployment, and database will consume this password to create to basically set password for the root account in database, and then it will create database service. And database service will register the DB hostname, and we will use DB hostname and DB pass variables as a feed to WordPress deployment in order to create the database connection string for WordPress and allow it to connect to the database. And we will finally expose the WordPress service. So that's how it's going to be working. These are going to be our steps. So let's get back to the demo. And here is our first resource. It's a MySQL password, the secret. And what we need to do is that we need to wrap this secret definition into this secret resource into a definition. We do it using AppController kubeac wrap command, and what's going to be outputted is, as you can see, the API version is going to be added, the kind definition is going to be added, the metadata is going to be added, and the rest is just our regular Kubernetes secret. And we will start feeding that data into the deps file. So what I'm going to do, I'm going to create the file with definitions. I'm going to be appending my definitions to this file. So first of all, we created this password definition. Then we would need to create the MySQL deployment and service. So there is another file which we just need to wrap. You will see that, yeah, I have my MySQL service here, MySQL deployment, which is like, backing pods. So what I'm going to do again, I'm going to wrap these into the definition and add it to the deps file. Before I do it, I'll just create some spacing for better readability. It's gonna be this one. Okay, and I'm gonna do the same with WordPress.
Yeah, so what I see in deps file right now is I see a number of definitions. First is the definition for MySQL password. That's the first node in the graph. Then there is a definition for WordPress, for MySQL service for WordPress. That's the other node in the graph. Then there is WordPress, the MySQL service, which actually takes as a feed MySQL root password from the secret that we specified earlier. And then there is the WordPress service and WordPress deployment. And WordPress deployment takes two things: the DNS host, the DNS name for database service, which gets registered in some previous step, which should be registered in some previous step, and also MySQL password from the secret. So you can see that there are a number of dependent items. And these are basically our nodes. So let's load them to Kubernetes. Yeah, you see that the definitions were created. What's important to note is, as I told you, like even though we loaded resources to Kubernetes, nothing gets provisioned because definition gives you ability to defer provisioning until you trigger it with the AppController. So our nodes got created. Now we need to connect them and create the dependencies. So I already have these dependencies pre-configured, and there is a number of them. So first is that there is like parent-child relationship. So we have MySQL needs to be MySQL password secret needs to be provisioned before WordPress deployment. WordPress deployment, MySQL deployment. Sorry, MySQL deployment needs to be provisioned before MySQL service. MySQL service should be provisioned before WordPress deployment, and WordPress service should be provisioned after the WordPress deployment. So we have like all the sequence here. We can actually, there is a quite fine tool which actually can facilitate creation of such graphs. So there's some sample graph preloaded, but if I load this YAML file, it's part of the AppController. So if I load this YAML into this tool, it will show you like how our graph is looking like. Actually, if you go to GitHub, and you go into examples of AppController and you go to extended examples, there are some dummy examples how graphs can be looking. And let's pull up another one. Deps, yeah, there is a lot more of those dependencies. Let's try to load this one and see how that looks, so that so that you can see like what dependencies can be modeled.
What is the graph builder? The one that shows the.
Sorry.
What tool is it? The graph builder.
Frankly speaking, I don't recall. So there may be some. No, there is no name for it, but yeah, if we load this graph, I mean, there is another example. We can actually run it inside AppController as well, so you can see that it allows to create like really complex dependencies. Yeah, our is really kind of simple. Okay, so let's get back to the console and let's load the edges of the graph. Again, we do kubectl create -f WordPress deps. Okay, so our graph is loaded into Kubernetes. We got our definitions. We got our dependencies, but nothing is provisioned yet. We just have only AppController running. So what we do right now, we trigger the deployment. So we do kubectl exec AC run, and you can see that, yeah, the pods keep getting provisioned.
the secret got created, and the same, like, deployments as well. 2 deployments have been created, and we can probably access the service right now. I'm running Minikube, so I'll do Minikube service WordPress, and yeah, it's working. And we can also see how the provisioning went by executing the get status command from AppController. You will see it will be basically checking whether all the resources have been provisioned and the status of them. So it's good for debugging. If something goes wrong, it will spit up the errors right here. So basically, that's how AppController works. I'm going to get back to the presentation. So yeah, just a quick recap of what AppController is doing. I mean, it frees you from running multiple kubectl commands when you deploy your complex application. And the application can be really complex in this case. You saw the examples of the graphs. There can be different jobs, different dependencies modeled. So yeah, it can get model quite complex applications. And I kind of try to anticipate a couple of questions that you might be asking. So yeah, I'm gonna go through them. So first question that people usually ask, I mean, we had a number of demos on Kubernetes community meeting of this tool, and also on other meetings, like SIGApps was another meeting where we demoed it, and people were coming up with different sorts of questions. And the first, I guess, the one that was quite frequently was like, if I interrupt the deployment in the middle of something goes wrong, what's going to happen? So AppController is idempotent, so it will re-go through the graph and recheck what resources have already been provisioned, and will pick up at the at the area of the graph where it encounters like first non-provisioned resource, and will continue from there. Can I run multiple AppControllers on a single Kubernetes installation? Yes, you can. You can run one AppController per namespace. What resources can be currently wrapped into definitions? So this is the list. We keep adding new ones. I think the most missing one for now is a volume, and we'll be working on it really soon. And the way of adding the resources is not really complex. I mean, you just need to extend the proper interface in AppController. How is provisioning of resources validated? So the question is basically, if I provision Kubernetes secret, how will AppController know that it's provisioned in order to continue with the next element of the graph? We read the statuses mostly from Kubernetes resources. So once Kubernetes announces a resource as provisioned, we continue with the next element of the graph. We also extend Kubernetes readiness probes. So for example, for replica sets, we have a custom success factor probe where you can specify the percentage of replicas that needs to be provisioned, like start the deployment of the next graph node when 40% of replicas are there, so that it doesn't need to wait for the whole replica set to be provisioned. What's on the roadmap? I guess what's coming on the roadmap actually in a couple of weeks is graph notifications, reactions, and error handling. So imagine a situation like, if you get back to our example, that you want to change this password. And the notifications and change handling will allow you to actually, via AppController, to trigger some actions on the dependent elements of the graph depending on the change in this element. So you can actually tell via AppController that if I change database password, please restart all the dependent containers to pick up the new secret and reconfigure themselves. So, okay, sorry, I went out of the presentation mode. Yeah, we're gonna be supporting more resources.
Also, yeah, the software is not perfect when it comes to usability. Like there is no, for example, kubectl describe. It doesn't support kubectl describe command. The resources that we actually, the third-party resources that we register. So we want to improve support for this. Also, we want to improve the better documentation, especially model real life applications and give examples inside the GitHub tree. I'm talking here about, like, frankly speaking, the kind of the main reason why we started designing this is that, well, Mirantis is an OpenStack company, and OpenStack is a microservice application, but not really best designed when it comes to like independency of layers. So like, you know, APIs heavily depend on database and messaging layers, so they need to be provisioned before you provision the APIs. And the AppController was our way to enhance management of OpenStack. So OpenStack is going to be probably one of the examples that we're going to give. Other ones we're thinking about, Ceph, also providing some failure handling in Galera, like, you know, services based on quorums. Yeah, so one question that some of you might be asking, like, yeah, we got init containers, so why do we need AppController? Init containers is another attempt to handle, like, to handle initialization of containers better and to do some preliminary steps before you start a container. So, for example, you can use init containers to prepare a volume for you that you can further expose to the app container. And basically the difference between init containers and AppController is that init containers, they don't really even want to support the graph deployments. It's just, they just give you like a little bit of preparatory steps before you provision your application container. So they don't aim to model like complex dependencies. Also, like, init containers are limited to container only. And in AppController, you can specify dependencies between like all sorts of elements in Kubernetes, like deployment, service, volume, like whatever you can imagine. The list like that we target to support is like all objects in Kubernetes to be supported in AppController. Also, it keeps debug logs in one place, so yeah, it's easier to your app is easier to maintain. And like the item on the roadmap that I told you, like, you know, it can react to changes in the graph where something gets reconfigured. You can trigger reconfiguration of dependent elements. That's, I guess, the most like added value from the AppController.